Hello everybody. In this video we are going to continue talking about SI units of temperature. So in the previous video we talked about Celsius and Kelvin very briefly, and we talked about average temperatures, we talked about the Celsius scale, and we talked about temperature differences. In this video we're going to focus mainly on Kelvin. Kelvin is the base unit of temperature in the SI system. So Kelvin and Celsius are closely related. The 0 degrees Kelvin, so that's what I mean here, 0K, 0 degrees Kelvin is considered to be the coldest temperature possible. And we refer to it as absolute zero. So if you want to look it up and read more about it, you can just look up absolute zero. Now, at absolute zero, theoretically, and I'm stressing that word theoretically, all matter stops moving. Particles stop moving, right? Now, this is all theoretical because, at least to my knowledge, we've never reached that temperature before, okay? At absolute zero, like I said, this is the coldest possible temperature, so we can't go below that. So 0 Kelvin is about negative 273 degrees Celsius. So yes, that is extremely cold. Now, the next point about the Kelvin and the Celsius scales is that they have the same divisions. Now, what does that mean? So let's say, for example, this is my thermometer for, say, degrees Celsius, and this is my thermometer for degrees Kelvin, for example. If this is one number, say number A, and this is number B, and from here to here, it's one jump. Let me actually just put actual numbers as opposed to A and B. I'm making these numbers up, okay, everybody? So let's say this is 1 to 2. On the Kelvin scale, if there's a number here, let's say 10, again, I'm making these up, this number would be 1 higher, 11. See what I mean? So the distance from here to here is equal to the distance from here to here between two consecutive numbers. This is what we mean when we say the divisions are the same, okay? What is an example of a situation where the divisions are not the same? So let's say we have some scale here, and this is 1 and this is 2. But the other scale, this is 1 and this is 2. So you see these divisions are not the same, okay? All right, moving on. Now let's talk about the freezing point of water. So we know that water freezes. It goes from liquid state to solid state at 0 degrees Celsius, right? So to compare that to Kelvin, that would be positive 270 degrees Kelvin, okay? So now on the screen, I have two formulas for you. One to help you convert from Celsius to Kelvin, and one to help you convert from Kelvin to Celsius. So this would be a very handy formula to write in your notes. Now, do you need to know both? Not really. You can always just work with one, but you may need to use some algebra at some point. If that's something you're not comfortable with, then perhaps just always refer to both formulas. So let's talk about the first situation. If you have Celsius, you know that number, and you're converting to Kelvin, you use this formula. So what do you do with it? You take the temperature for Celsius and you put it here. You will know that number. Then you add 273, and it's going to spit out the degree in Kelvin, okay? Now, if you have the degree in Kelvin and you want the degree in Celsius, you put this temperature over here, you subtract 273, and then the answer will be the temperature in Celsius, okay? So let me erase all of that so you can take a screenshot or write it down. And now we are going to try a few examples. So I'm going to be moving the page up and down multiple times so I can refer back to the formulas. So we're going to practice. I'm going to zoom out a little bit just in case you want to pause the video and try these questions by yourself first. Okay? Always make sure that you check your answers after you attempt them. Okay, so here I have a Kelvin and Celsius scales, and I just wanted to zoom in and show you what I mean by equal division of scales. So notice here that when you go from 0 to 10, from here to here, the same distance, we're going 10. We're going from 273 to 283, so we're adding 10, right? So the divisions are the same. And I'm just going to show you again the absolute zero. This is absolute zero right here, okay? And that's at negative 273 degrees Celsius. and here is the boiling point of water, 100 degrees, and it's 373 Kelvin. Now, you're noticing these commas. Don't worry too much about them. These are decimal points. In some languages, we use a comma as opposed to a point to show the decimal. All right, now let's try a few practice questions. The first three questions here, if you notice, we are given the temperature in Celsius and the Kelvin is missing. So we're going from Celsius to Kelvin. Let's go up to our formula, Celsius to Kelvin. So we are using this formula. Kelvin equals degrees Celsius plus 273. Just for ease, I'm going to just write it here so I don't keep moving the page up and down. Okay, so I will use this formula for these three questions. So let's get started. I'm going to show my work in detail. So here I'm going to say K is equal to 37 degrees, because that's the degree in Celsius, plus 273. And that is going to equal, I don't have my calculator on me, so I'll do it by hand. So this is 11, so 310 degrees, or not degrees, 310 Kelvin. Okay, so this is 310. Okay. Now for the next one, we have the degree in Celsius. So Kelvin equals Celsius plus 273. The degree Celsius is 100 plus 273. So that's 373 Kelvin. Got to put the units, 373. Now, last question. We have a negative temperature, but that's okay. We treat this the exact same way. And again, you are more than welcome to use your calculators if you're not comfortable with negatives. So negative 15 here plus 273. Please excuse me as I try to do it over here. So this will be 8, 5, and 2. So 258 Kelvin. And I'm just going to box these up so they are clear. And you don't have to verify on the scale, but let's just do it for fun. So let me check 37 degrees Celsius on the scale. That is around here. And yes, that makes sense. It's around 310 over here. 100 degrees Celsius, yes, it's 373. And then the last one, negative 15. Let's go to negative 15. So that's right here in the center. So that's about 258. Absolutely. We are doing a good job. All right, let's continue. Now, the next question here, we are asked to convert from Kelvin to Celsius now. Okay, so we're given the temperature in Kelvin, we want it in Celsius. So let's go up to our formula. Kelvin to Celsius is right here, and this is the formula. I'm going to write it down at the bottom. Okay, so Celsius equals Kelvin minus 273. Okay, now I know the degree in Kelvin, that's 294, minus 273. What is that in Celsius? That is going to be 21 degrees Celsius. Okay, and let's check our work. So I'm going to go to 294 on my scale. So this is 293. This is 294 right above it. Oh, there it is at 21. We are correct. Okay, so this is how we convert from Celsius to Kelvin and Kelvin to Celsius. Remember, Kelvin is the base unit of temperature in the SI system, and 0 degrees Kelvin is absolute zero, the coldest temperature ever, theoretically. All right, make sure to practice, and best of luck.